Alright, it says if the probability of A is 0.3, probability of B is 0.2, the probability of B given A is 1/3, find the following. Okay, so before we can find those following, in a sense, we need to do a table. So what I'm going to do is to copy that over here so I can see this probabilities. Alright, and I'm going to make my table. And to show you that I don't have to put the A on top, I'll put the B's on top and the A's down the side. Alright, probability of A, 0.3. Probability of B, 0.2. Okay. Total probabilities have to add up to 1. Since probability of A plus probability of A bar is equal to 1, probability of A bar must be equal to 0.7. Similarly, 0.2 plus probability of B bar is equal to 1, so probability of B bar is 0.8. And then we're given the probability of B given A. We cannot put that into the table because the elements in this table now are A and B bar, etc. Alright, so we have probability of B given A. Alright, what form of the multiplication rule would we use to help us utilize that? Well, we have the two events, A and B, and the order over here on the left-hand side doesn't matter, so we can say the probability of A and B is equal to the probability of something times the probability of B given A. Right? Since it's conditioned on A, the first event must be A. Right? So we can't have probability of A times the probability of A given B. We can't have the A first twice. Right? So if the B is first once, the A is first once. Alright, so the probability of A and B is equal to the probability of A times the probability of B given A. Probability of A we know is 0.3 times B given A we're given as 1/3. Alright, so the answer to that is 0.1, so the probability of A and B, which is in the first element here, is 0.1. Okay, and then we can work out all the other elements in that table. 0.1 plus something is 0.2, so that's also 0.1. 0.1 plus point something is 0.3, so it's 0.2 to make that work. And finally, 0.1 times something is 0.7, so it's 0.6. Okay, and there's our table. All right, once we have our table, then we can answer the rest. All right, so let's go back to our problem here. All right, so the first question, A and B. Actually, we've just worked that out, right? But at this point, we'll just read from the table, 0.1. Okay, that element there. Second, probability of A and B bar. Again, it's a joint probability. We read directly from the table. A and B bar. This value here is 0.2. All right, C, probability of B given A. Okay, well, let's write out a version of the multiplication rule that involves that condition. All right, just to make sure we've got the right thing. It's B given A. All right. It's going to be probability of A times probability of B given A. And some of you will be noticing that this is exactly what we've been given before in the problem. So we know what the answer is. It's 1/3. But let's be a little dense here and work it out from the table. So rearranging this formula is probability of A and B divided by the probability of A, probability of A and B, from the table. All right, it's the 0.1 top left-hand corner. Sorry, I'm going the wrong way. Divided by probability of A from the table. It's 0.3 over here. And of course we get our 1/3, but remember this is given by the problem. So it's sort of a nearly meaningless question. Alright, let's look at D. Probability of B bar given A. Alright. After you see the answer to this, then you'll know why C was asked before D was asked. Alright, so we'll go through the same routine. So we have two events. It doesn't matter the order. I'll just put them in the order that looks nicer alphabetically. Alright, so we have the probability of conditioned B bar given A over here. So the first event over here, since condition on A, must be A. Alright, so rearranging that, probability B bar given A is the probability of A and B bar divided by the probability of A. Some of you will get to the point that you will look at a formula like this and say, how do I make this formula from this point instead of rearranging the first one? Alright, so I have a conditional probability of B bar given A. Alright, so on the top line I have these two events, A and B bar, and it doesn't matter the order. I can say probability of A and B bar or B bar and A. And on the bottom, what do I have? Well, whatever's conditioned over here, right, gets put over here. Okay, that's sort of a quick way of doing that. Alright, so let's go back to our table, find the probability of A and B bar. A and B bar is this number that's circled here, divided by the probability of A. Well, it's still 0.3. Alright, and that's 2/3. And why did I say that I did C first before I did D? Just to make a point here. These two are complements of each other. So the 1/3 and 2/3 is not a coincidence. Okay, so the events probability of B given A and the event B bar given A are complements. Why? Well, let me write this first. They're both conditioned on A. Okay, and of course B and B bar are complements as long as the condition is the same. The events will be complements, okay, because the first part of the events are complements. Alright, look what else we have here. E, probability of A bar given B bar. Alright, let's try to do it the way I just pointed out before. So we have the probability on the top line of the two events with and between them, A bar and B, and we divide by the probability of what's conditioned over here, probability B bar. Okay, so let's go back to probability A bar and B bar. Alright, it's a 0.6 over here. Divided by the probability of B bar. Probability of B bar is 0.8. Alright, and that's 3/4 or 0.75. Alright, F. Are A and B mutually exclusive? If A and B are mutually exclusive, we'll just abbreviate ME. Alright, this comes from material from the addition rule. Then the probability of A and B is equal to 0. Right? Mutually exclusive means they cannot occur at the same time. But from the table, probability of A and B, scroll up there quickly, probability of A and B is equal to 0.1, which of course is not 0. So the two events, A and B, are not mutually exclusive. Okay, so that's that. And we'll look at the last one, G. Are A and B independent? This comes from our definition of independence. If A and B are independent, then probability of the joint probability of A and B is equal to the probability of A times the probability of B. Right? Remember that only occurs if they're independent. And probability of A and B, right? We have that somewhere. Right? Is 0.1, and we check that against the probability of A. Right? Which is 0.3. Probability of B 0.2, and it turns out to be 0.06. Right, these two are not equal, and so the events A and B are not independent, or if you like, A and B are dependent. All right, and that's that question. Let's now look at the next problem. Same type of problem. What I want you to do here is to try this problem yourself before you watch me do it on the video. So write down this information, or just pause the video here and do the problem. And then when you have done the best you can on all those parts, continue the video and see if you've got the right answer.